Welcome to aminacademy.com. In Laplace transform, let us do Laplace transform of some basic functions. Let the function is Laplace transform of sine at. By definition, Laplace transform of some function is integral 0 to infinity e power minus st into that function, that is sine at dt. Now this function is by using by parts, we can do integration by parts. First function is e power minus st, second function is sine at. That is by parts. We have first function integral of second is minus cos at over a minus integral of differential of first e power minus st, differentiation is minus s into e power minus st into integral of second is minus cos at over a dt. 0 to infinity, here also 0 to infinity. Now let us give the limits of infinity and 0 in first term, that is e power minus infinity is 0, means the complete term becomes 0, and if you give 0 for this, that is e power here minus e power minus st, that is e power 0 is anything power 0 is 1, and cos 0 is also 1, 1 into 1 is 1, then minus is already there, here one more minus, it plus, that is 1 over a minus, here this minus and minus, 3 minuses are there, so it is plus, and take out s over a and integral 0 to infinity, then e power minus st into cos at dt. Now equal 1 over a plus s over a is common, and here 0 to infinity integral e power minus st into cos at, we have to do one more time by parts. Here the first function is e power minus st, and integral of second cos at integral is sine at over a minus integral of 0 to infinity integral of differential of first, differential of e power minus st is minus s into e power minus st, and integral of cos at is sine at over a dt. Here the first function you have to give 0 to infinity, so we have 1 over a plus s over a. Now we will give the limits of infinity and 0 here. E power minus infinity is 0, so everything becomes 0. Now minus, if we give the 0 of sine 0, e power minus 0, that is e power anything, e power 0 is 1, but sine 0 is 0, so it is become completely 0. After that, here minus of this, here this is, here 3 minuses is there, here minus, then here also minus here, then minus, then you can say after that here minus into minus plus, but put plus first. Then here put the limit of, look at this here, integral 0 to infinity e power minus st into sine at is already a Laplace transform of sine at. So first we will take out this s over a out of integration, then 0 to infinity e power minus st into sine at dt. So it is a Laplace transform of sine at. So we'll continue like here, 1 by a minus s into s is s here, square over a square into Laplace transform of sine at. This already we started with Laplace of sine at. Now collecting sine, Laplace of sine at one side, Laplace transform of sine at plus a square over a square of Laplace of sine at equal 1 over a. Now factorize Laplace of sine at into 1 plus a square over a square equal 1 over a. Now Laplace of sine at equal common a square into a square plus a square equal 1 over a. Now we can say Laplace of sine at equal 1 over a square plus a square over a square. Therefore Laplace of sine at equal 1 over a into a square over reciprocal multiplication, that is a square plus a square. Now the square cut, this cut, therefore Laplace of sine at equal a over a square plus a square. This is our final answer of Laplace transform of sine at equal a over a square plus a square. Now this we can write in order. Laplace of sine at equal a over a square over a square. Now one more method we can do Laplace transform of sine at, like first we will change the color. Laplace of sine at equal, for that we will keep first Laplace of cos at plus I sine at. By De Moivre's theorem we can write cos at plus I sine at as we can write as Laplace of e power I at. Now we know that Laplace transform of e power I at equal one over s minus ia. Now we will write 1 over s minus ia by using conjugate multiplication into conjugate of s minus ia is s plus ia over s plus ia equal s plus ia over s square plus a square, because I square is minus 1. Now comparing imaginary part, since imaginary part have sine function, imaginary part both side, we have Laplace of, here imaginary is here, that is Laplace of sine at, Laplace transform of sine at equal, here that imaginary parts of that here the function is a over s square plus a square. We got a same result. We have done. Please subscribe our YouTube channel.